Oh, that intro, that is just the superhero intro, is it not? That's what we're headed towards with this integration, eventual integration work we're going to do. Now, this is lecture 3, where I'm going to try to help those of you who don't have a TR-8S be successful with your own drum machine and making your own drum machine rhythm performer a superhero, because not everybody has a TR-8S. I get that, right? But something you will need are assignable outs. And you can see the assignable outs on the TR-8S are assignable trigger outs. Well, on your drum machine, you will need to have some assignable outs that allow you to take an instrument sound, and port it out to a mono cable that you can then use as a faux trigger. I'm going to show you how to do all of that. We'll step through it piece by piece here, and hopefully at the end of this video, you too will be able to take your drum machine, whatever it is, even though it doesn't have trigger outs, and make it a trigger out superhero. So first, a little bit of theory. We're going to go to the Telestrator. So let's head on over. So let's take a few minutes here. I'm going to build this off of a book from Alan Strange. In it, in his chapter Voltage Control, he has a picture of an envelope. I think most of us, who have been doing this for a while, have heard of the ADSR envelope, the attack, decay, sustain, release envelope. And actually there's a gate along with it, right? That's drawn in the time domain, and people say time domain. So let's hold on a second here and take a couple of steps back. So I'm digging out my craft project here, X-Acto blade and all that, and I'm going to make myself a piece of equipment. We could call it a device of some kind. It can be whatever. We'll call it a sensor, right? A sensor device, E-N-S-O-R. And what the sensor sees is in this window. In fact, our synthesizers have sensors that are waiting to detect voltage, to do something. So there's some voltage window that our device needs to see. And there's likely some threshold as well, some voltage threshold that maybe makes something happen with the sensor or the device. So now it's going to go ahead. That's our sensor, our device. And I'm going to go ahead and I'm going to draw this attack, decay, sustain, release. Attack, decay, sustain, release. And for those of you who are astute, attack, decay, sustain, release, you're going to be saying, oh my word, he's just drawn that backwards. Just hang with me, okay? What the device sensor sees as it's looking for voltage over time, whether it's looking for a trigger or to change a volume, it's zipping along, sniffing for voltage. There it is. And now it sees a voltage, and it's going to do something, right? It may be, I'm going to increase a volume, or I'm going to increase an attenuation, or I'm going to modulate a filter. And as it goes along in that window, there might also be a trigger involved, where if it reaches a certain voltage, it says, you've reached a threshold voltage, I am now going to fire a trigger. Or it could be a gate. It says, it's time for me to open a gate. And as long as the voltage is above that threshold, right, the gate will open. The gate will stay open. The gate will stay open. And then all of a sudden now, as it's sniffing up, it drops below that voltage and the gate shuts off. Or if it's been doing an attenuation or a modification of a cutoff on a filter or a volume, you're going to begin to see a change of that device's output. It's going to go down, 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 down to 0, and then the device will be fully shut off. Sensors don't know anything about time, all right? All they know about is voltage. When we draw the classic attack, decay, sustain, release envelope, what we're really drawing, let me dry this, right? What we're really doing here, is we draw, you saw it in the picture from Alan Strange's book. We have this attack, we have this decay. This is the more typical sustain, and release. That's A, D, S, R. And now it is in the time domain. It's not in the sensor's window of view anymore. It's looking at time. This time is earlier. This time is later, time 1 to time 2. So while we draw it in this direction, what the sensor is seeing is in its own viewpoint. We're drawing this in the viewpoint of time. So again, what the sensor sees is sort of backwards from that. It doesn't know anything about time, but for our use, for us to be able to evaluate a voltage profile of some kind, we, for convenience in the time domain, because it's something we can understand, we look at our envelopes and our voltages for gates and triggers in the time domain. And this is important because it's what we're going to attempt to do with our trigger, our faux trigger, for our not TR-8S drum machine. Okay, so now, TR-8S. The TR-8S, we'll draw that in blue because it matches my electric blue sliders, right? And there's going to be a voltage pulse, a trigger pulse, and it's going to peak out. I think it peaks out at somewhere around maybe 10 volts, something like that. I think somewhere around 10 volts. I'd have to verify it, but we'll just go ahead and say TR-8S. It's way more than you need because most devices, most Eurorack modules and semi-module devices, when they look for a trigger pulse, they're looking for somewhere around 5 volts. So you can see here, I've drawn it not to scale. It exceeds that 5 volts. All right, and there is a rising edge voltage. We'll put that in green as a rising edge voltage and a falling edge voltage. We talked about this before when we did the sample and hold lecture. I think that might have been lecture 7 on the MS-20, right? So this was a leading edge of that signal, and this is a trailing edge of that signal. But this is a voltage rise and a voltage fall, and most devices are triggered with a rising edge voltage that achieves some threshold. That's the output of the TR-8. And as a matter of fact, here's the time. We're in the time domain here, right? And remember we said the last slide, it was time 1 to time 2, T1 in the time domain. On the TR-8S, the difference between T1 and T2 is 4 milliseconds. 4 milliseconds, folks. That's about the speed of a bumblebee's wing flapping. This is wicked fast. Va-poof, va-poof, right? Those triggers are what then trigger a other device to do something, to begin its envelope. So, non-TR-8S drum machine. So let's say you have a drum machine. It needs to have assignable outs, but it doesn't have assignable trigger outs. And note I've changed the axis on my graph to be equally disposed, and there's a reason for that. We're going to pick a sound for an instrument on your drum machine that gives you the greatest chance of creating that boof, that trigger, right? We need to have a sound energy that is converted to voltage, because all sound is converted to a voltage when we listen to it from our ears. So what I mean by that is, think about this. Let's say I have, and we're going to choose a rim shot. A rim shot's typically a really good voice for this task of creating a faux trigger, because a rim shot typically, and we'll see a picture of it from the oscilloscope. A rim shot typically goes whoop, right? And then it comes down and then goes back up. And you'd say, wait a minute, I thought I needed a positive voltage, and you're drawing for me down here a negative voltage? And again, this is in the time domain. And the answer is yes, but think about what it's doing. It's attempting to move a speaker coil, right? And to move a speaker coil to make sound, right? Speaker to make sound. It's supposed to be a musical instrument, a musical treble clef there. Oh, that is a mess. But anyway, you have to move a speaker cone in and out on that coil, which means you need a positive and negative voltage to make that coil go woof woof. Well, we're going to take that woof, because we don't need the woof woof, we only need one woof, that woof, and hopefully spike that voltage high enough to exceed the threshold needed, which is typically 5 volts. So that's our goal. Our goal is to pick a sound for an instrument, and we'll play with the rim shot, because that's typically really good, and we have to exceed 5 volts of signal out, of analog signal out, to make it a faux trigger. That's our goal. Okay, so let's say you don't have a TR-8S that has the perfect trigger, 4 millisecond trigger out. Well, the hack I am recommending is a rim shot. You can program in a rim shot to an assignable out of your own drum machine. A rim shot's going to have a pretty solid thwack. It'll be pretty fast. You may have to do a couple of hacks with it though. Even though you have a perfect thwack of a rim shot, you may have to modulate it slightly so that it's loud enough that it can bust through and give you a V trigger, if you will, a sound voltage spike V trigger that will exceed the threshold required to trigger, let's say, a drummer from another mother or some other device. Let me show you how that works. Here, I'm setting up my ride cymbal. This is a TR editor, Roland TR editor, but you can do this directly on your drum machine. And I've got my output set to a sine 6, which in this particular case is going to be a rim shot. And what you might find yourself needing to do is actually boosting the gain a bit to make sure you get enough of a signal out so that when your device is listening, it can hear the voltage spike of the sound associated with the rim shot. And then I start my TR, or your drum machine, whatever that is, and you're going to slowly increase your volume until your device you're trying to sequence reads your rim shot. So again, it's not going to be a typical V trigger. You're kind of doing a hack and utilizing a rim shot to do that. I just realized I forgot to start this lecture the way I start every other lecture, and that is, Princess Leia hairdo on? Check. What am I, losing my mind? And no, you don't have to answer that question. Anyway, so the hack I'm proposing then is the rim shot to give us that sonic pulse, that voltage spike from your assignable out. You don't have an assignable trigger out with a, you might, but if you don't, then you need something. The rim shot is the recommendation, the boosted gain rim shot. And then once you've got that set up, like I say, make sure you move that slider slowly forward as you seek to find the voltage that your companion device needs to trigger and advance. You don't need to go too far with it. The machine is simply looking for, as we showed, the machine is looking, your device, your companion device is looking for just enough voltage to say, I understand that. It doesn't hear the sound. What it does is it feels the voltage. There may be some questions with this video. So, because it's we're into new territory, right? If you have questions setting up your own drum machine, I am happy to help. Absolutely, I'll do everything I can. I don't have a companion drum machine. I only have my TR-8S, but I'm willing to do what I can. So leave your questions. And much like at the university, oftentimes when our discussion pages with the discussions going, students often answer the questions that other students asked. which is great. So I might not have the answer because I don't have a different drum machine, but other viewers might. So our community will get your question answered and we'll get your drum machine up and running like my TR-8S. And then you can use yours and I can use my TR-8S and we can move forward with the next steps here. And the next steps are going to be integration. From here on out, every lecture will be integration of some unit. And the first one will be my DFAM, my drummer for another mother. And then from there we'll go to other units, stuff that I own, and hopefully then you can apply what I am showing you to your own modular and semi-modular rig. So that's next up, integration lectures. I think that's all I have. And I guess at this point I'll say, I'll talk to you later.